Okay, this is just a test to see if this actually works. So let's get the pen. Let's go for a nice, well, not red, let's go for purple. Was that magenta? Was that fuchsia? Right, so we're given this u equals a half kx squared. That's just, yeah, the potential. That's just a useful bit of information. So it's probably a ball bearing. You can imagine a ball bearing at the end of the spring moving up and down, bouncing up and down. Sometimes it's got kinetic energy, sometimes it's all kinetic energy, sometimes it's going to be at an instant in time, it's just going to be all elastic potential energy. Of course, this looks like more of a quantum thing, but this is why you study oscillators, the most simple one, and mass on the spring, because it's very similar to what happens to particles moving at the quantum level. So E, this is the important equation, equals p squared over 2m, oops, I don't know why I did that, plus a half k x squared. So we got that, and you can see which one is going to be, if we just change the pen to green, this is basically elastic potential energy. I mean, it's not elastic potential at the quantum level, but it's potential energy, so maybe get rid of that. And this is kinetic energy as well. Now it also tells us that you can use the uncertainty principle, and you can say px is approximately equal to h. So we're going to say px is equal to h for this. So let's have a look at that. The first thing to do is we've got to look at this equation here, equation 2, and we've got to come up with an energy equation that gets rid of p and just has x in it, and you'll see why in a second. So we can rearrange that. Therefore x equals h over p, and we can sub that in. We're going to call that equation 3, and we can sub that and say 3 there, it does now, and we can sub 3 into equation 2, which is good news. So we're going to do that. So we know that if we rearrange this, we've got x equals h over p. We can also, actually we don't need that, we need, ignore what I just said, we need p equals h over x, and that is equation 3. That's just another equation. So if we stick that in the equation, we know that p squared equals h squared over x squared, and we can stick that into there. So now what we have is E equals, we put that in, I'm just going to, yeah, we're going to get h squared over 2m, and I'm writing in this format because these are all constants, times by 1 over x squared. So we've rewritten the kinetic energy part in terms of x, and we still got the original half k x squared. Now we have an equation which just has x in it. There's no p in there, so that's quite good. Now it says, it talks about a minimum. So it talks about a minimum. We've got an equation here. I've plotted this graph. Over here as this. I've got rid of the constants, but just so you can see the shape of the graph. It's 1 over x squared plus a half x squared. Of course, you've got the constants there. Now you can see there's minimums there, so there's definitely a minimum. We've got to find that, and you'll know from your year 12 calculus that to find a minimum you do dE over dx in this case equals 0. So we need to differentiate that. So what is dE over x? Because that's what's on the graph. Just to make sure, we got x here, we've got E here. You know, it's just a function. That's why you learn all this maths. And that becomes, if I look at that, that's going to become h squared, we've still got those factors there, 2m, nice easy differentiate 1 over x squared is going to be minus 2x to the minus 3, because 1 over x squared is x to the minus 2, plus, I'm going to differentiate that, a half k 2x, which is really good news because we can see lots of cancellations there. So one of the things you notice that you can do is you can cancel out those 2's there you go, and those 2's there, and you're left with, hopefully, which equals, so I might as well do it, dE over dx equals, what have we got here? We got h squared over m times by x, oops, not x, got to be careful here, it's not that at all, times by 1 over x cubed. And I'm just keeping it separate because I like to keep the constants a little bit separate from the actual variables. And this one here is just, well, I guess that's just plus kx, which you might recognize from A level, force equals kx and all that. So change of energy over x is actually force, which is quite interesting. But yeah, we don't have to worry about that for that. So we got that, and so we now need to set that to 0. So 0 equals h squared over m 1 over x cubed plus kx. And I did forget something because there's a minus there. That's actually minus. That's minus there as well, because yeah, because when you differentiate, the 1 over x squared, that's minus 2x. There's a minus there. So that's quite handy because then we just got h squared over, I'm just going to write it all together, mx cubed equals kx. So if we just divide through, well, what can we do here? I'll tell you what we're going to do here. We're going to multiply everything by x cubed. So we end up with h squared over m, what's going to happen there, equals k x to the 4, which, if we go up here, I'm going to carry on there, which is going to equal, let's have a look here, so that's, and we rearrange it again, we're going to get x4 equals h squared over, we've got to divide by k, over mk. So we're almost there, mk, and then finally x, this is the value of x where there's a minimum, equals, well, when you cube it's plus or minus, isn't it? So we're only going to choose one of them, plus or minus. So let's do that again, make it a bit clearer. I'm sure there's a quicker way of doing this, but this is the more formal way. Equals plus or minus, because you're, x4, x squared, it's the same thing. Plus or minus the 4th root of h squared over mk, which is where the actual minimums are, as you can see from the graph over here, whatever that is. So if we, so there's definitely 2 there. Now we've got the value of x, now we need to go back to the original equation. So what I'm going to do here is just separate that a little bit because it gets too mushy, but that's the key result, which is this. That's where we know is the actual minimum. So we're just going to sub that in, blah 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 blah. So let's have a look. X equals plus or minus that. So we're just going to put that in. So we start off, I'm going to change color just because this is like a separate thing. So let's go back to the original equation. E equals h squared over 2m 1 over x squared plus a half kx squared. So really now this is just going to test your algebra more than anything. So we're going to sub in our value for x. So we have e equals h squared over 2m 1 over. I'm just going to do every single step just so you can see, because the algebra can sometimes be a little bit tricky. H squared over mk. So we got that plus a half. Almost forgot something there. Put the bracket around there because it's squared. It's 1 over x squared plus a half k. And we've got that. It's exactly the same thing. I'm going to put a bracket around it because it's x squared. And we know x is the root, the fourth root of h squared over mk. So now we have lots of fun with this. So let's simplify it. So we got e equals h squared over 2m. I'm going to do each step times by 1 over. That just becomes, you know, because the power of 4, well, the fourth root is the same as a quarter. You know, your indices rules, a quarter times 2 is a half. So that ends up becoming the square root of h squared over mk plus a half k. And we've got the same thing over here, times by the root of h squared over mk. So we got all that, fantastic. So that's all doing that. Looking at this, in maths we don't like that. I've missed something out. What have I missed out? So yeah, it's root of h squared. Sorry, I've got to be very careful here. So you've got to make sure, because it's so easy to make a careless mistake with that. So if I just do that, go back to blue, it's the root of the whole of h squared. Now, you know your third rules, that can be written there. So I'm going to go back to some of the, you know, the algebraic maths that helps you simplify these things. So it might be a bit boring, but I'm going to do every step. Equals 1 over third rules, root of h squared over root of mk. That's the same as that. Plus a half k. That's not k to the 4 up there. That's the that should be, what have I done there? Oh yeah, so that becomes that k. I don't know why I put that there. You can see I'm getting tired of this. Let's get rid of that. That shouldn't be there. Half k, let's double check. Yeah, h squared. Yep, that's, everything's back to normal. A half k root h squared over the root of mk. So e equals h squared over 2m equals, I'm doing it, no, it's not equals, it's dot. So annoying. Let's get rid of that. So it's just saying times, I'm just getting a constant out. Right, focus. It's just relentless, this question, but it's a classic way of proving it. Equals 1 over h over the root of mk plus a half k times by h over the root of mk. So we got all that, fantastic, because we can't do that. This is really annoying because you remember there's a couple of things we can tidy this up, so we've got to tidy this up, so hopefully we can fit this all in one screen for this problem. H squared over 2m times by root mk, because it's like the reciprocal, over h. I think you're happy with that. So let's just double check. We've got yeah, that's all fantastic. Brilliant. Plus, you can see what we got here. We got a third at the bottom. Not very nice. We don't like that. So we rationalize the third. So we're going to times the top and the bottom by root mk, because root mk divided by root mk is 1, so it's not going to make any difference, but that means we end up getting plus a half k h. This goes on forever, this question. Root, but it is a standard proof. Over root mk over mk. So still looking a bit messy. Is anything we can cancel out? Yeah, oh, well, yeah, there is something we can cancel out. Let's have a look. What can we cancel out of this? So we've got m there. Let's have a double check. What can we take out of that? So we've got 8 squared over 2m there. We've got root mk, yeah, over h. Well, I guess we can take h over m outside. So let's factorize this. Oh, the classic maths is coming back. How exciting. E, I'm going to just take h over m out as a factor. I'm going to put a big square bracket there. So we're left with h over 2 root mk over h plus a half, what are we taking outside? A half k. I've got to be careful here because I kind of made that a little bit too long, that bit there, because it is, you know, when I rationalize the third, it's just root mk over mk plus a half k. What are we taking outside? We're taking an h and we're taking out an m, so that means we're left with a half k root mk over mk. Now you can start to see there's some cancellations that go on here, which is going to make life easy. They disappear, they disappear. So we're left with, we're almost there, thankfully. I'm losing the will to live. H over m is equal to, we've got all that, h over m. Left with, what have we got? We've got, oh, this is looking good. Root mk over 2 plus, well, half, plus root mk over 2. So we've got that, which is fantastic. So let's have a look at that, which is, okay, so we got all that, fantastic. So that equals, that implies we're getting there eventually. E equals h over m. I'm going to keep the square brackets just so it matches. Root mk. And that's the same as, and here we go, E, bit of third action, h over m. I'm just going to write it as indice form. Root mk is the same as, well, you know, root m k is the same as root m root k, because the third rules, which is the same as m to the half k to the half. So I could write that because it's a little bit clearer. So we've got m to the half, k to the half, almost there. Look at that little m down there. Let's multiply out m to, at the bottom, that's actually m to the minus 1. So we can write this out as E equals h, and we're just m to the minus 1, because that's what h over m is, times by m to the half, that was in brackets, k to the half, and we're left with, let's have a look. So I think we've got all that. We end up with, let's double check if I've done this right. So h m to the minus 1 equals m to the half k to the half. So we've got, okay, so that equals, well, m to the minus 1 plus m to the half is going to be, well, that's going to equal h m to the half. And that's just k to the half. I think we're almost there. Let's just double check. No, minus a half. Oh, naughty, naughty. Minus a 1 plus a half is not a half, it's minus a half, which is the same as h, Well, that's the same as minus half is basically the same as root m. That's the same as root k, which equals h root k over m, which is the final answer, I believe. Is that what we're trying to do? Yeah, but it is a good thing to know all the little steps there, so it really, really does test your algebra. Have fun. Bye.